In this lecture, we're going to study the outage that happened at Facebook a few years ago. So this outage happened on 23rd September 2010, and during this outage, Facebook was unreachable for 2.5 hours. This was the worst outage in the past 4 years leading up to then at Facebook. Facebook published a postmortem after the outage was resolved, and all the information you're seeing on this particular lecture is from that postmortem. Once again, our goal in studying this outage is not to say that Facebook is a bad infrastructure. In fact, it is a very robust infrastructure. And during the outage, Facebook was very open and honest with its users about what was going on. And after the outage, Facebook improved their infrastructure and continues to improve its infrastructure to avoid such outages. And as you know, Facebook continues to be one of the market leaders in the area of social networks. So a little bit of background before we discuss the actual outage itself. In Facebook, data is stored in a persistent store as well as in a cache. Okay, so the persistent store has many servers that are essentially the back-end servers storing the data. And the data includes things like Facebook profiles, the updates, the status updates that you post, the friend information, photographs, and so on and so forth. The cache is another set of servers that is closer to the clients, that is running a distributed cache system. So the cache servers sit in between the persistent store servers on the one end and the actual client machines, the user machines, your browser and your mobile device on the other end. This system that includes a persistent store and cache includes configuration data, and Facebook has an automated system for verifying the configuration values in the cache servers. Whenever a particular configuration value is invalid, the cache server replaces it with updated correct values that it fetches from the store, from the persistent store servers. So on September 23rd, Facebook made a change to the persistent copy of a particular configuration. Unfortunately, that particular change was invalid. Okay, so this is where the human operator mistake comes into play that triggers this particular outage. When this invalid change was made, all the clients, when I say clients here, I mean Facebook cache servers, not your mobile device and your browser. So throughout this, when I say clients, throughout this outage, when I say clients, I mean Facebook cache servers. When these clients, these Facebook cache servers saw this invalid value, all of them attempted to fix it all at once. All of them queried this cluster of databases, the persistent store, to fetch the updated value. And the databases were quickly overwhelmed by these hundreds of thousands of queries per second coming from these cache servers. Pretty quickly, the team discovered this and fixed the invalid configuration. And at this point, you might start to think, well, okay, so now the outage is starting to recover or should start to recover. But as we have seen before with outages, they keep cascading because of other factors that come into play as well. When a client, meaning the Facebook cache server, received an error from a database, it interpreted this as invalid and deleted the corresponding cache entry. So essentially, when a database failed to respond, the client created even more requests to send to the database layer, to the persistent stored layer. So you can see this bad cascading loop happening where the database has an error, the cache servers see this error, they try to fetch information from the database, but because the database network is overwhelmed by these hundreds of thousands of queries per second, the cache server times out and panics, and it tries to query the database even more aggressively, or at least as aggressively as before. And this keeps the network always in a bad state and stuck in this bad state. In other words, there is no back off. The cache servers did not slow down sending their rate of queries when they saw congestion in the underlying from the database itself. Okay, so this rinse and repeat cycle led to the cascading failures, and the outage kept propagating and continuing in this particular case. Facebook's solution eventually was to realize that they had to turn off the entire Facebook website. This stopped all the traffic to the database cluster, and the database started to recover. They slowly allowed users back on. This also meant slowly allowing the cache servers to come online, and the cache servers slowly started to update their caches. This kept the traffic to the database, the persistent stored layer, pretty low. But allowing these cache servers on in stages took a while, and it took until later in the day for the entire site to be back up. So what lessons do we learn from this particular outage case study? Well, first of all, a new configuration system design is what Facebook built after this outage to avoid exactly outages of this kind. The second was that when you cannot access a resource, in this case the cache is unable to access the database copy of a configuration value, you should not try aggressively to try to access the resource again. Okay? Don't try as hard or harder to try to access the resource. Instead, back off, which means that wait longer than you waited the last time to try to access the resource. So each time a request fails, you wait twice as long as last time. That's a potential solution. This is often known as exponential backoff. Such an approach is used in networking protocols like 802.11 as well as in transport layer protocols like TCP to avoid congestion. A similar approach may be needed when it comes to the data center layer in terms of avoiding such outages.